A force is an interaction between objects that may change the motion of an object. A force is exerted on an object, and has a giver and receiver. For example, when you push the door, you exert a force on the door. You are the giver of this force, and the door is the receiver. A force is a vector that has both magnitude and direction. The unit for force is Newton, or N. Coplanar forces are 2D forces that are on the same plane. We only need to deal with coplanar forces in this syllabus, and don't have to worry about 3D forces. Now let's see how to resolve a force. To resolve a force is to decompose the force into two components. It is the reverse process of adding two vectors. We know forces are vectors. When we add two vectors, we can use the parallelogram rule like this, and the red vector is the sum. Now we are given a force, and two directions. We can make a parallelogram based on the two directions, with the given force as the diagonal. And the two red forces are the two components of the given force. Their sum is the given force. You can see it is a reverse process of adding two forces or vectors. The two directions can be random. Given two random direction and a force, we can always make a parallelogram with the given force as the diagonal. Hence resolve the given force into two components. The most common way is to resolve a force in two perpendicular directions, one horizontal and one vertical. This way, we can use simple trigonometry to find the value of the two components. This is a force of 6 Newton with an angle of 60 degrees to the horizontal. We can resolve it to the horizontal and vertical directions. The horizontal component points right. Its magnitude is 6 cosine 60 degrees, which is 3 Newton. The vertical component points up. Its magnitude is 6 sine 60 degrees, which is 3 root 3 Newton. This is a force of 4 Newton with an angle of 45 degrees to the horizontal. We can resolve it to the horizontal and vertical directions. The horizontal component points right. Its magnitude is 4 cosine 45 degrees, which is 2 root 2 Newton. The vertical component points down. Its magnitude is 4 sine 45 degrees, which is also 2 root 2 Newton. Resultant is the vector sum of forces. To find the resultant of multiple forces, we resolve them all on the horizontal and vertical directions, find the resultant on these two directions, and then compose or combine them. Let's look at an example. Find the resultant of these three forces. One is 6 Newton, pointing upwards, and having an angle of 60 degrees with x positive. One is 4 Newton, pointing upwards, and having an angle of 30 degrees with x negative. One is 4 Newton, pointing downwards, and having an angle of 45 degrees with x negative. Let's resolve them all onto the x and y directions. The 6 Newton force is resolved into a 3 Newton force pointing right, and a 3 root 3 Newton force pointing up. The 4 Newton force pointing upwards is resolved into a 2 Newton force pointing up, and a 2 root 3 Newton force pointing left. The 4 Newton force pointing downwards is resolved into a 2 root 2 Newton force pointing left, and a 2 root 2 Newton force pointing down. Now let's combine the components on the x and y directions separately. On the y direction, the resultant points up, and the magnitude is 3 root 3 plus 2 minus 2 root 2. This is 4.3677 Newton. On the x direction, the resultant points left, and the magnitude is 2 root 3 plus 2 root 2 minus 3. This is 3.2925 Newton. So the resultant is the diagonal of the rectangle. Its magnitude is the root of 4.3677 squared plus 3.2925 squared, which is 5.47 Newton. To find theta, or its angle with x negative, we can use inverse tangent, 4.3677 over 3.2925. This is 53.0 degrees. Remember, force is a vector. So you need to find out both the magnitude and the direction of the resultant. If we are trying to find the resultant of only two vectors, we can use the triangle rule, and resolve the triangle. For example, find the resultant of these two forces. To use the triangle rule, we need to connect vectors head to tail. So we move the 4 Newton force to connect head to tail with the 6 Newton force. And its angle with the horizontal is still 45 degrees. This is the resultant. Since the two dashed lines are parallel, this angle is 60 degrees. So in the triangle, we have two sides as 4 and 6 Newton, and their included angle as 105 degrees. Therefore, using the cosine rule, we can find the magnitude of the resultant. It is the root of 4 squared plus 6 squared minus 2 times 4 times 6 times cosine 105 degrees, which is 8.03 Newton. Suppose the bottom angle in the triangle is theta. We can use the sine rule to find theta. 4 over sine theta equals 8.03 over sine 105 degrees. Using the calculator, we can find theta as 28.8 degrees. Therefore, the resultant's angle with x positive is 60 plus theta, which is 88.8 degrees. In this class, we learned: a force is a vector. The unit of force is Newton, or N. A force can be resolved into two components. To find the resultant of multiple forces, resolve them on the horizontal and vertical directions first, calculate the resultant on each direction, and then combine them. Triangle rule can be used to find the resultant of two forces.